Okay, this next bit of these algebra techniques is what's called partial fractions. And as it says there, we need this process to help with graphing and with calculus. So we can use these partial fractions for those two things that we will do later. So first of all, thought just see what partial fractions are to start with and work with them to start with, and then after that, later in the year, we'll then do some applications of it. All right, so what is partial fractions? Well, say I've got, say, 5/6. Now, I can break 5/6 up. I can say that 5/6 is 3/6 plus, oops, not 2/6, 1/6, 2/6, and that would be correct. Then I can cancel down. 3 goes into itself once, and into 6 twice, and 2 goes into itself once, and 6 3 times. So effectively, partial fractions is what I've just done there. Is I've taken my original fraction and I've broken it up into the sum of some other fractions. Now you'll notice, and we'll look at this and we'll use this, you'll notice that what was in the denominator there and these two denominators are factors of this one. All right, so we'll use that. All right, so resolving into partial fractions is a process where a fraction is expressed as a sum of simpler fractions. And here's an example. This one's already been done for you. So 4x plus 2 over x squared minus 1 is equivalent to 3 over x minus 1 plus 1 over x plus 1. And so these three lines here equivalent to is what they mean. All right, it's a technical mathematical thing that we put there rather than equals, and it's because we're not doing a sum. We're not doing a sum, so or an equation. So we don't use the equals. We use the equivalent. We say that this fraction is the same as or equivalent to the sum of these fractions. All right. So as I kind of mentioned up here, these denominators are factors of that, and when you look here, these two are factors of x squared minus 1. So if we have a factorized denominator, there's some templates that we use to do this. All right, so if we've got a factorized denominator, we've got some function on top and we've got two other functions, so f, g and h. Nothing special about the letters f, g and h other than they're different to indicate that there's different functions. So g and h are the factors, and so there we go, there and there, and there's something, and I've just called them a and b on the top there. All right, so how can we use this? How can we proceed? So it says express x minus 5 over x plus 3 times x plus 1 as partial fractions. So first of all, we say, all right, well, x minus 5 over x minus plus 3, x plus 1, will be equivalent to a over one of the factors, x plus 3, plus b over the other factor. All right, that's nice. Then what we need to do is we go, okay, so if it's equivalent, for us to find out what this a and this b are, we need to make the right-hand side look more like the left-hand side. And so to do that, what I need to do is multiply top and bottom of this one by x plus 1, top and bottom of this one by x plus 3, and so then what I have is a times x take plus 1 plus b times x plus 3 over the denominator x plus 3 times x plus 1. Now, if these two things, excuse me, these two things are equivalent to each other, the denominators are the same. So what that means is our numerators must be the same as well. So rather than writing out our denominators already, because we already know they're the same, but for those two to be equivalent, our numerators have got to be the same. So x minus 5 is got to equal a x plus 1 plus b x plus 3. Let's expand here. So x minus 5 is ax plus a plus bx plus 3b. Collecting some like terms together. Actually, I don't even need to. Actually, this is one way of doing it, and this is kind of the long way of doing it. It's all right, I'll do it the long way. So x minus 5, these have got x's, so a plus b, x plus a plus 3b. So then, equating coefficients is, we go then, if it's 1 there, a plus b, it's got to equal 1, and a plus 3b, it's got to equal negative 5. If I then take away a minus a is 0, b minus 3b is minus 2b, and 1 minus is 6, so b is negative 3. So a minus 3 is equal to 1, a is equal to 4 then. I think. Oh, it's not. Yes, it is. That's right. A plus b, a is 4. All right. So, what do we got then? What we've got then is that what we started with, x minus 5 over x plus 3 times x plus 1 is equivalent to a, up here, coming back up here, a, oops, and a is 4, so it's equivalent to 4 over x plus 3, and then minus 3 on x plus 1. All right, and so there's our equation there. Or our partial fractions. All right. Okay, the next one is when we have a square in the denominator. All right, so say for example, let's go and I'll just choose a number. Say the number 9, for example. What are, and 9 is 3 squared. So what are the factors of 9? Well, factors of 9 are 9, 3, and also 1 goes in everything. And so, but we don't have to worry about the factor of 1. But what we do need to do when we split it up is we need to take into account all of the other factors. And that's what this indicates here. So if you've got something squared, then over here for our partial fractions, we need that something, but we also need the something squared, because that something squared, in this case 3 squared, 9, is also a factor. All right, we need to represent all factors. So now, why that's decided to pop up and not disappear. Stupid thing. All right, you just have to deal with that, and hopefully it goes. Oh, let's see if it go to the calculator, then come back to there. No, go back to here. Look at here we are. Gone. All right, so express 2x minus 3 over 4x minus 7 squared as partial fractions. Okay, so the factors are 4x takes 7, and the other one is 4x takes 7 squared. All right. So what do we got to do? We got to multiply top and bottom here by 4x takes 7. Which would be a times 4x takes 7 plus b over 4x takes 7 squared. And remember again, because these things are equivalent or the same, then our numerators have got to be the same. So 2x minus 3 has got to equal to a times 4x takes 7 plus b. So 2x minus 3, 4ax minus 7a plus b. So looking at coefficients of x, 2 has got to equal 4a. So a has got to equal half. And the other bit, minus 3, is going to equal this here. For the constant bit, it's got to equal minus 7 times a half, because we found a plus b. Minus 3 equals negative 7 halves plus b. It's a big B, better put a big B in, not a little b. And then that as halves would be minus 6 halves plus 7 halves is b. So b is a half also. So when you have a one of those coefficients that is a fraction, what we do is this. We just squeeze it in over here. So a is 1/2, so we put the half, the 2 there, down the bottom. 4x take 7 plus b is a half, 4x take 7 squared. All right, and so 2x minus 3 over 4x take 7 squared is equivalent to that. All right, that's that one. Next one, denominator not factorized. You have to factorize it. All right, so this one here, negative x minus 15 over x squared minus 9 expressed as partial fractions. So negative x minus 15 over x squared minus 9 Well, that's the same as negative x minus 15 x minus 3x plus 3. So that's then equivalent to a over x take 3 plus b over x plus 3. All right, then put it over the same denominator. So I'm going to multiply top and bottom on this one here by x plus 3. Top and bottom here by x take 3. And then for those fractions to be equivalent, then negative x minus 15 is equal to a x plus 3 plus b x take 3. All right. Now, before, when I expanded, collected, like terms, I said it's kind of the long way around. There is a shorter way around. And the shorter way around is you have a look at what you've got here and here. And so, first of all, let's look at this one. And I say to myself, all right, what do I need to make x for this bracket to equal 0? And I go, okay, I need to make x negative 3. So, when x is equal to negative 3, I substitute it in. So I've got a negative there, a negative 3, so it's 3 minus 15 equals a minus 3 plus 3 plus b minus 3 minus 3. Now this here is equal to 0. So what that means is we've got 0 lots of a and we've got minus 6 lots of b. So from that, we know that b then should be 2. I hope. Yep. Then I can do the same thing and I'll look at this. So to make this bracket equal 0, x is 3. So when x is equal to 3, I've got minus 3, minus 15 equals a, 3 plus 3, plus b, 3 minus 3. And then this bit is equal to 0. So what I have then is I have that minus 18 is equal to 6a, and from that, a is minus 3. So my equivalent fractions, negative x minus 15 over x squared minus 9, is equivalent to a, well, I'm going to swap them around. I'm going to write them the other way around, just because I can then put the negative here. I think that's right. Yeah, the a is over the minus 3. All right, and so there's that, if it's not factorised. All right, there's a little bit more to go, so again, I apologise for the length of this particular one, but there's a few different formats that we need to look through. But if you need a break, have a stop, have a breather, count to 10, turn around. I would stand on your head, but perhaps that's not a good thing in class. All right. So if our degree of our numerator is greater than or equal to the degree of the denominator, we need to divide the expression first. So what that means is that our power of x up here has got to be less than this one. If it's not, we divide. And so here's an example. See, here's both x squared. So we divide. Okay, so there's a long division way of dividing this, and so I'm going to borrow from long division. If you're not overly confident with long division, and you're not sure about what's going on here, make sure you ask. Whoops, that's 52. All right, so the way we do this is we say, all right, let me start with the x squared. To get 5x squared, I'm going to have to multiply x squared by 5. And so 5x squared gives me 5x squared times x squared. And now I multiply this 5 by each of these things. So I've got 5x squared plus 10x there. Minus 8, 5 8s are 40, minus 40. And then what I'm going to do is I'm going to subtract this line from the one above to see what I've got left after I've multiplied that by 5, because I'm trying to get this here in the end. All right, 5x squared, take 5x squared, nothing. 10x, take 10x, nothing. Negative 52 minus is plus, so I've got negative 52 plus 40, which is negative 12. And that's it, that's as far as I can go. So what have I got here? Well, what I've got here is that the fraction 5x squared plus 10x minus 52 over x squared plus 2x minus 8 can be expressed as 5 plus whatever the remainder is. Now the remainder here is minus 12, so it's minus 12. The remainder, what's the remainder? The remainder is out of x squared plus 2x minus plus, I made a mistake, minus, I did make a mistake, no, in the end, because it was minus 8. All right. So now we've got that. What I need to do is the partial fractions. I only need to now do the partial fractions on this bit. All right, so I just need to do the partial fractions on this bit, and then I can bring that back and put it back in there. All right, so let's do the partial fractions on that. So I'm going to go negative 12 over x squared plus 2x take 8 is equivalent to a plus b. All right, the factors, two numbers that multiply to 8 and, don't really need these brackets here, but anyway, multiply to give you negative 8 and add to give you 2, so I'm going plus 4 and minus 2. I reckon that would be right. All right, so let's now give that a common denominator. So this one's a x take 2 plus b x plus 4 over x plus 4 x take 2. And so again, if they're equivalent, our numerators are the same. So negative 12 is going to be the same as a x minus 2 plus minus 2 plus b x plus 4. All right, you're choosing x values. If it's 2, that's 0. So when x equals 2, you get minus 12 a 2 minus 2 plus b 2 plus 4. So minus 12 is equal to 6b. B is minus 2. All right, the other one is this one. So when x is minus 4, you get minus 12 equals a times minus 4 minus 2 plus b, which which is minus 4 plus 4. And so we've got negative 12 equals negative 6a. A is 2. So when we go all the way back to the start here, I haven't left myself enough space, then when I put in the equivalent fraction, let me write it here. Yep, let me write it here. Where are we? Here, no, here. Let me write it here. So I'll write it over here. So this here is equivalent to 5, and the A, let me just check what the A is, 2. So 5 plus 2 over x plus 4. And the B was minus 2. So minus 2 over x, take 2. All right, and so there's the partial fraction version of that there. All right, divided out. Now, after all of that, the good news is we can use our calculator. Yay. So in your main menu, action, transformation, expand. And there's a little trick, and I'll show you the trick. So, main menu, we're in the main menu. Action, transformation, expand. What are we expanding? We're expanding some fraction, and this particular one is 2x cubed minus 5x squared plus 3x plus 7 over x squared minus x minus 2. Now here's the little trick thing that you need to remember, is you need to say, because you want it to expand for something, what do you want to expand for? You want to expand for x. Alright, so you want to expand for x, and then when you go exe, it will do it for you, and there it is, expanded. Now if I didn't put the x there's not necessarily a guarantee that it's going to do it properly. Sometimes it will, sometimes it won't. Let's just have a look with this one here. And so exe, so it gives, look at this, look what it's given here. So all it's done here is split up the terms on the top and given them that denominator. So it hasn't done it into partial fractions. So to get it into partial fractions, you've got to put this comma x on the end. All right, so that means that our answer that we had there, the equivalent was 2x plus 1 over x plus 1 plus 3 over x minus 2 minus 3. All right. So if we're doing some integration calculus on this thing, and we've now got that, that makes life a lot easier for us. All right, so it's quite it's totally different new concepts to you there, so you work through it, get assistance when you need to, and as always, have fun.